Alright, so this is the chemistry section 12.3 lesson video part 1. I'm going to break this section into two parts because there's two different types of problems that we learn. So a couple of things that you'll want out during this section are, of course, a periodic table. And if you're still struggling a little bit with the 3-step stoichiometry problem, you may want to get a mole map out. Remember, I gave you one in class, or you can find it on my website. Or you can just Google it. I did not create the mole map. I made that one, but I didn't create the concept. Alright, so in 12.3, we're going to learn two things. We're going to learn how to do limiting reagent problems and percent yield problems. In this video, I'm just going to do limiting reagent problems. So in a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of products that form. So we're about to build a sandwich. So let's say you're studying for your stoichiometry test, of course, and you're just like, oh my gosh, I'm hungry. I'm going to go down and make a sandwich. So when you're going downstairs, you start thinking about what you want on your sandwich. So you're like, I'm going to start with 2 pieces of bread. I'm going to add 1 slice of cheese. I'm going to put on there 3 slices of turkey. And let's say 2 leaves of lettuce. And that's going to make my sandwich. 2 slices of bread, 1 slice of cheese, 3 slices of turkey, and 2 leaves of lettuce. 2 slices of lettuce. Alright, so then as you start going downstairs though, you're like, wait a minute, I'm not like one sandwich hungry, I'm like so hungry I want to eat every sandwich in our house. So you're like, I'm not just going to make one, I'm going to literally make as many as I possibly can. So you go to your pantry and you're like, okay, bread, where's the bread? And let's say that you pull 20 slices of bread out of your pantry. Alright, then you go to the refrigerator and you grab a pack of cheese. Let's say that you have 5 slices of cheese in your pack of cheese. You pull out the turkey. Let's say you have, 60 slices of turkey. It was a big family-sized pack of turkey. Alright, and then you pull out your head of lettuce, and let's say you had, 10 leaves of lettuce. So now you're ready to start making your sandwich. Well, you make one, you make another one, you make another one, you make another one, but eventually what's going to happen? Eventually you're going to start running out of ingredients. Okay, so let's figure out when that would happen. Alright, so for bread, you need 2 slices of bread for a sandwich. You have 20. So if it only depended on bread, you could get 10 sandwiches. That's a pretty good amount of sandwiches. Alright, you need 1 slice of cheese for each sandwich. You found 5 slices of cheese. So how many sandwiches could you make with your cheese? Well, you can only make 5 sandwiches before you run out of cheese. Alright, you need 3 slices of turkey for each sandwich. And you found that gigantic family-sized pack that had 60 slices of turkey. So you can make 20 sandwiches with the amount of turkey that you have. And then for lettuce, you want to put 2 leaves of lettuce on there, but you have 10, so you could make 5 sandwiches. So now that you know how many sandwiches all your ingredients could make, how many complete sandwiches are you going to end up with? You're going to end up with 5. Because what's going to happen is after 5 sandwiches, you're going to be out of cheese and lettuce. Now, when you're making a sandwich, could you obviously substitute ingredients? Like I could make a sandwich without cheese if I wanted to. Why would you? But you could. Or you could go and find something else to put on there. But in a reaction, you can't just substitute like that. Once something runs out, the reaction has to stop. Alright, and so that's what we're doing, is we're trying to figure out if we start with all of this stuff, how much product are we going to make? So what you're going to get is you're going to get 2 amounts. I'm not going to give you 4. You're going to get 2 amounts for your reactants, and you're going to have to figure out how much product are you going to make. So notice, did we pick the highest number of sandwiches possible? No, we picked the lowest, because limiting reagents always make the lowest amount, L and L. Alright, the limiting makes the lowest. Alright, so unfortunately, it's not going to be quite as easy math as this was. I wish it was. But, chemistry is a little bit more difficult than making a sandwich. So we're going to do our basic 3-step stoichiometry problems. So if you did not listen to the end of the last lesson video, you do not need to watch this one until you are comfortable doing this. Alright, so let's move on because I'll assume you're comfortable. So a limiting reagent is fully consumed in the reaction and determines the amount of product produced. An excess reagent is not fully consumed in the reaction, so some is left over. So for example, in our sandwich example we just did, that huge family pack of turkey, you're going to have a bunch of that left over. That would be an excess reagent. Whereas the cheese and the lettuce ran out, so those would be limiting. And then what was our other ingredient? Oh, and bread would also be excess because there would be some bread left over. So let's just jump in and look at how to do one of these. I'm not going to lie, these are like the longest problems that you'll do in this entire class. But I personally love them. Again, the better you are at the 3-step stoichiometry problem, the easier this will be. So it says, what is the maximum number of grams of Cu2S, so we're looking for grams, that can be formed when 80 grams of copper reacts with 25 grams of sulfur? So what looks different about this problem than in section 12.2 is we now have 2 starting amounts instead of just 1. In section 12.2, we would have 1 starting amount, we would have a question mark, and we go from here to here, and that's our answer. Well, now you just have to do it twice. I know, it's like, oh my gosh, those problems are so long. That's why you need to get good at them. So then when you have to do it twice, it's not a big deal. All right, so what we need to do is, like with our sandwiches, we wrote down all our ingredients, and then we figured out how many sandwiches we could make with each, and then we picked which one? The lowest. So that's what we're going to have to do. We're going to have to do a problem from here to here and get an answer, then do a totally separate problem from here to here and get an answer, and then our final amount that we'll actually produce is going to be the lower of the 2, just like when we picked the 5 sandwiches. All right, so let's go ahead and start. So just forget about sulfur for right now. We are going from 80 grams of copper to how many grams of product will we get? All right, so I start with what I know. That's 80 grams of copper. Now for the 3-step problem part, I'm going to go a little bit faster than I did in section 12.2 because I'm going to assume you got that now. So step 1 is convert to moles. I have grams, so I'm going to use molar mass. Copper on the periodic table is about 64. So I follow my golden rule and I put my 64 grams on bottom, and molar mass always equals 1 mole. So I put my 1 mole on top. All right, so my grams cancel. And remember, 64 just came off the periodic table. All right, step 2 is mole ratio. So 2 moles of copper make 1 mole of my product. So I follow my golden rule. Moles of copper go on bottom. I pull my coefficient. 2 moles of copper equals 1 mole of my product. And so moles of copper cancel. So then I move on to step 3. Convert to unit asked for. So it asks for grams of my product, Cu2S. So I have to use molar mass again, but this time I'm going to use molar mass for Cu2S. So I have to add it up off the periodic table. So Cu is 64 times 2, and S is 32. And when I add that up, I get 160 grams. So I follow my golden rule, and I put the mole on bottom. So Cu2S, how many moles? Remember, molar mass always equals 1 mole. And whoops, what did I say for molar mass? Oh, 160. And then I put my 160 that I added up off the periodic table on top. So my moles of Cu2S cancel. I got grams of Cu2S like the question has asked me for. So I'm ready to solve. So remember, you just multiply across the top, 80 times 160, and divide by the bottom, 64 and 2. And so when you do that, you're going to get 100 grams of Cu2S. Now, we don't know if that's the right answer yet, because think about our sandwich example. We had to go through and find out how many sandwiches for each ingredient before we knew how many sandwiches we could make in total. So now I need to go back and worry about, well, how much would I have made if I used sulfur instead? Okay, so now we're going to pretend like copper's gone, and we're just going to go from 25 grams of sulfur to grams of our product. So I start with what I know, and that's 25 grams of sulfur. All right, and first step is, of course, convert to moles. Since I have grams, I'm going to use the molar mass. So sulfur on the periodic table is 32 grams. So I'm going to put my grams of sulfur on bottom. That equals, of course, my 32 grams. And then molar mass always equals 1 mole. So my grams of sulfur cancel. I'll move on to step 2. Step 2 is mole ratio. So in this case, 1 mole of sulfur equals 1 mole of my product. So I follow my golden rule. Moles of sulfur goes on bottom. How much? 1, because I use my coefficient. Remember, mole ratio is always based off the coefficient. And that makes 1 mole of my product, which is Cu2S. So my moles of sulfur cancel. See how nice it is? Just cancel. Like, I like to check it off as I go each time. You should do the same. Just saying. Alright, so last step is convert to unit asked for. Now I know you're looking at this thinking, oh my God, when is this problem going to end? The answer is never. However, one thing that I can offer you is in a limiting reagent problem. See how we're trying to get to the same product both times? These last 2 steps will be the same. That's the only shortcut I can give you, unfortunately. Okay, because we're trying to get to Cu2S, we already added up the molar mass right there, and of course your mole of Cu2S is going to go on bottom. So that's the only shortcut I can give you for this, is that those last steps will be the same. So you don't have to re-add up the molar mass, because the thing is you're going to the same product both times. Alright, so you can multiply across the top, divide across the bottom, and so for this I get 125 grams of Cu2S. So what this means is if all 80 grams of copper get to react, I'll make 100 grams of product. If all 25 grams of sulfur get to react, I will make 125 grams of product. But the problem is, once we make 100, we're out of copper. So we're never going to make that last 25 that sulfur could make. There's just going to be some extra sulfur. So once you're done, only box in the correct answer. Like, that's the problem, is I get a bunch of papers and your paper looks like this. And you just expect me to know that you knew it was the lowest one. Well, I assume you had no idea what you were doing because you boxed both of them in. Okay, so don't box in both answers. Only box in the one you want me to see. Now, some of the questions will then ask you to identify the limiting reagent and the excess reagent. So I'm just going to call it LR for limiting reagent and ER for excess reagent. So this is how you do it. Whoever made the lowest is the limiting reagent. So this is not the limiting reagent, it's who made that. So you find the smallest one and go back to the beginning. So copper is the limiting reagent. And then whoever made the higher amount, which is sulfur, is the excess reagent. Okay, a lot of you like to tell me that Cu2S is the limiting and excess reagent. That doesn't make sense. Reagent is another word for reactant, and Cu2S is a product. Alright, so you find the lowest amount, and what made that is the limiting reagent, copper. You find the higher amount, and what made that is excess reagent, in this case sulfur. Alright, so these problems, they're just kind of long, and they're very tedious if you're not good at a 3-step problem. So y'all, you got to get good at it. You got to do 2 of them just to get the answer to one question on this type. Alright, so let's move on and look at another one, and then you can try the last one. Or maybe there's 3 more. I don't remember how many more there are. Alright, so there's all my answers. Alright, so yeah, it looks like we have 2 more. So I will do the top one, and then I'll let you try the bottom one. So it says unless you're feeling confident, you can go ahead and try this one. If 75.6 grams of C2H4 is reacted with 201.6 grams of O2, how many grams of CO2 is produced? Okay, so notice we're not worried about water at all. So remember, you're just going to do 2 3-step problems. We're going to go from C2H4 to carbon dioxide, then we're going to go from oxygen to carbon dioxide. And again, I'm going to go kind of quickly through the 3 steps because I'm going to assume you've got that by now. Alright, so I'm going to start with the 75.6 grams first. Ooh, I didn't leave myself a lot of room to work these out. Alright, so step 1, of course, is convert to moles. Since I have grams, I'm going to use the molar mass. So when you add up C2H4 off of the periodic table, you get about 28 grams. I'm I'm going to put the grams on bottom because I'm following the golden rule. So 28 grams equals molar mass always equals 1 mole. So my grams of C2H4 cancel. All right, I move on to step 2. Step 2 is the mole ratio. So 1 mole of C2H4 makes 2 moles of carbon dioxide. So I follow my golden rule. Moles of C2H4 have to go on bottom. So it is 1, and that's going to make 2 moles of carbon dioxide. So my moles of C2H4 cancel. Last step is I need to convert to unit asked for. Well, it asks for grams of CO2. Well, I'm going to have to use the molar mass. So when I add up CO2 off the periodic table, I get 44. So then I follow my golden rule. Moles of CO2 has to go on bottom. Now remember, molar mass always equals 1 mole. And that equals 44 grams because we added that up off the periodic table. So moles of CO2 cancel. So last step is I'll multiply across the top, divide across the bottom. Make sure you're trying that and you can get these answers. So I get 237.6 grams of CO2. Now we don't know if that's the correct answer yet or not. We have to look at oxygen also. Alright, so then we do another 3-step problem. But this time we're going to focus on the oxygen. Okay, so here we're going to pretend like this isn't here and we're going to go from oxygen to carbon dioxide. So I start with what I know, and that's that I have 201.6 grams of oxygen. So step 1 says convert to moles. Well, since I gave you grams, we're going to use molar mass. So oxygen 16 times 2, so that's 32 grams from the periodic table. I'm going to follow my golden rule and put grams on bottom, which I just told you was going to be 32. Molar mass always equals 1 mole. So I put 1 mole oxygen on top. Step 2 is mole ratio. So 3 moles of oxygen makes 2 moles of carbon dioxide. So I follow my golden rule. Moles of oxygen is going to go on bottom. It's going to be 3, and that makes 2 moles of carbon dioxide. So moles of oxygen cancel. Alright, last step, remember this is the one shortcut I can give you. Last step is the same. Okay, so I'm not even going to explain it, I'm just going to write it down. So I put my last step as the same, and then I just multiply across the top and divide across the bottom. So when I multiply across the top and divide on the bottom, I get 184.8 grams of CO2. So how much am I actually going to make? I'm going to make the lower amount because once I get to 184.8, I will be out of oxygen. And so the C2H4 can't keep reacting. So remember, sometimes I'll ask you to identify the limiting and excess reagent. So who made the lowest? O2 made the lowest. So it's the limiting. Who made the higher amount? C2H4 did, so it's the excess. Okay, I can't stress enough. You find the lowest and then go back to the beginning. That's how you know which reagent is which. Alright, so what I want you to do is I want you to try this one. Just pause the video, try it. Well, here, I'll at least set it up for you. I'm probably going to erase up here and do part of it up here and part of it down here because I just didn't leave myself enough room. Alright, so let me at least help you set it up real quick, unless you're feeling super confident. Alright, so it says when 6 grams of HCl reacts with 5 grams of magnesium, how many grams of magnesium chloride is produced? So we're not worried about hydrogen here. Sorry, this is a question mark. It kind of looked like a 7 with a decimal. Alright, so remember what you're going to do is you're going to go from 5 grams of magnesium to our product, and then from 6 grams of HCl to our product, and then you pick the lowest. So pause the video, try it. Don't forget to identify which one's limiting and which one's excess. Alright, I'll assume you've done that now. So what I'm going to do is I'm going to do the magnesium portion up here. Alright, so I'm going to start with 5 grams of magnesium because you always start with your given. Step 1 is convert to moles. Well, since I gave you grams, you're going to use molar mass. On the periodic table, magnesium is about 24. So I'll follow my golden rule and put grams on bottom. It's 24 on the periodic table, and then molar mass always equals 1 mole. So grams of magnesium cancel. Next step, mole ratio. So 1 mole of magnesium equals 1 mole of my product. So I follow my golden rule. Mole of magnesium goes on bottom. How many? Well, look at the coefficient, it's 1. equals what? 1 mole of my product, which is MgCl2. Some moles of magnesium cancel. All right, so last step is that we need to get to the unit asked for. So the unit asked for is grams of MgCl2. Since it's grams, I'm going to have to use molar mass. If you hadn't realized, I like doing molar mass a lot. So a lot of your problems will have molar mass. You're welcome. All right, so Mg is about 24, Cl is about 35 times 2. So once I add all that up, I get 94 grams. So I follow my golden rule and put mole on bottom. How many? Well, molar mass always equals 1. And, oh, I forgot how many grams I just said. 94 grams. And make sure that you can get these molar masses. I always round to a whole number when I do it in class. So that's where I get my numbers from, is I round to a whole number. Now when I do stuff for a test or a quiz, or a lot of times when I do my answers for this, I'll go out 2 decimal places. So that's why sometimes you'll see some inconsistencies. All right, so last step is multiply across the top, divide by the bottom. And so for this one, I got 7.83 grams of MgCl2. But I don't know if that's the correct answer yet, because I have to go back and look at HCl. So I'm going to do that one down here. So remember, this belongs down here. So I start with my 6 grams of HCl. First step is convert to moles. Since I have grams, I'm going to use molar mass. So H is 1, Cl is about 35 on the periodic table, so that's 36 grams. So I follow my golden rule and put grams of HCl on bottom, and I just told you it's 36 when I add it up. Molar mass always equals 1 mole, so 1 mole goes on top. So grams of HCl cancel. So step 2 is mole ratio. So in this case, 2 moles of HCl equal 1 mole of my product. So I follow my golden rule and put moles of HCl on bottom. I put 2 because that's the coefficient, and that equals 1 mole of my product. 1 mole MgCl2 because that is the coefficient for that. All right, last step is I convert to the unit asked for. In this case, they asked me for grams, but remember, here's our one shortcut. I know it's going to be the same as the previous third step. Okay, so I put my 1 mole of MgCl2 on bottom and my 94 grams on top. And so my moles of MgCl2 cancel, and so then I just multiply across the top, divide across the bottom, and I got 19.58 grams of MgCl2. Whoops, see, I almost boxed it in. I do that every now and then because I'm so used to just boxing in my answer. So, which one are we actually going to make? Well, once we make the lowest amount, 7.83, we're going to be out of magnesium. So this is how much we will actually produce, because we'll be out of magnesium before we make this much. So what's my limiting reagent? Well, remember, I find the lowest, and I'll look at what made the lowest. So magnesium is the limiting. That means once we make this much, there's no magnesium left. The excess makes the higher amount. So here's my higher amount, so I go back to the front. HCl is the excess. All right, so hopefully you at least got part of that right. Like even if you only got, one of the answers, or you at least had some of the steps right, hopefully you at least did that. All right, so this is limiting reagent. There is one more type, so I know you're probably thinking, oh my God, how can it possibly get any longer? Well, the next type is not longer. It's actually shorter than this. So hopefully it won't be that bad. But either way, just keep in mind that stoichiometry is the best, and so you're just going to have to accept that.